Hey guys, we're going to go through the test today. So if you didn't get every single thing right, this will help you out and make sure you understand what all your errors are. So we started off with this chain of reasoning. The chain of reasoning is going to kind of be a background thing running from now on. It should look like the right-hand side of the proofs, but we won't be doing a whole lot more logic like this. If mom is married, then she will bake brownies. If mom isn't married, then you didn't pass. If you turn the television off, so I'm going to call it turning off, it's a T, then you will study. If you study, then you will pass. And if you are not happy, then mom didn't bake brownies. Okay, so the opposite of that one. I've got to identify one place where a letter appears only once, and I could use the T to start off with. I could also use the not H. Okay, so my next one has got to say S goes to something. Let's see if I have something. Oh yeah, S goes to P. My next one has got to say that P goes somewhere. Where does P go? I don't have one, but I do have this, which I can take the contrapositive of. So P goes to M. I have a M goes to B, and one more contrapositive. Let's see that B goes to H. The bottom line is that if this happens, those things happen, those things happen, those things happen, those things happen, and eventually this happens. So if I turn the television off, if I suppose you turn the TV off, then H happens, then you are happy. Then you are happy. And a little moral to that story in there. Okay, the next one, given the diagram, is C, between. And this is, of course, the geometric word between D and B. In order for a point to be between another two, it has to be collinear first. And if there were a line drawn, then which contained B, C, and D, then we could assume that it is collinear. But if there's not a line drawn, even if we get out a ruler and see whether or not it seems to fit, it's not something we are allowed to assume. So we have to say no to be between you, or a point, really, but not you, must be collinear, and you can't assume collinearity. If that line were drawn, yes, you would be allowed to assume betweenness, but not as is. Okay, I got a few people on this one. Write yes or no, and then justify your answer. Is AE, that's you, is congruent to EB? Does CE bisect the angle ACE, this big angle? Does it get split into two congruent angles if those two segments are congruent? Sure looks like it, but that's almost the sucker's bet there, because the answer is, in fact, no. So in order for an angle to be bisected, it needs to be split into two congruent angles. Although it looks like it, we're kind of making some assumptions. So no, we may not assume angles are congruent. Some people made up some theorems, which are just made up, which say, oh yeah, if segments are congruent, then angles are going to be congruent, which is not necessarily true. Let me just redraw this diagram here. And say, okay, let's look at that, where that guy and that guy are congruent. Does it mean that that angle and that angle are congruent? Certainly doesn't look like it anymore, and yet it doesn't violate any of the things that are going on over here. Okay, number 4, by and large, very successful on this one. Really, what do the tick marks say? They say that the angle, this one on top, I could call it angle 1, but it is known as angle BAD, angle bad, is congruent to angle DAC, congruent to angle DAC. I could also have referred to the angle as DAB, DAB, and or CAD, but I couldn't call it like angle D or angle A or angle ABD or anything like that. Well, what does it imply when two adjacent angles are congruent? It implies that the larger one got bisected. So something along the lines of AD, the book would insist that it's a ray. I don't care so much. The ray AD bisects angle BAC. The big word I was looking for there was bisect. Bisected. Again, kind of like above, this angle kind of does look bisected, but those two segments now don't look congruent. Okay, this, a lot of it in thinking of all the cases and a lot of it in the justification. So pretty much everyone got if the 3 points were collinear, A, X, and B, and saying that those two things are congruent. Can we conclude that X is between A and B? Well, in this case, it certainly is, but nobody said that those points were collinear. So I could do A, X, and B, and I'll mark those as being congruent to each other, although not necessarily congruent to this example. And now X is not between A and B because the geometric definition of betweenness implies collinearity. So my answer, of course, is sometimes. Big hint, if you're ever confused, it's probably sometimes. In this case, I would say in this case, X is between A and B because they are collinear. And in this case, X is not between because the points are not collinear. That was really using that definition of collinearity. I could have done it in an if and an then. If a point appears to be between and is collinear, then it is between. If it does not, if they are not collinear, then it is not. I wanted to use an if and a then, but definitely using that definition at least. Okay, proof. Super important. We most certainly will be seeing these on pretty much every test in the near future. In step 1, maybe also in step 2, I'm going to write down the givens. Angle BAC equals 35 degrees. The measure of angle CAD equals 35 degrees, and one that was given. Some people did this in 2 steps. Perfectly fine. Some people said the measure of angle BAC and BAD are 35 degrees. Also fine. No problem there. 2, well, what is implied by them having the same measure? It implies that they are congruent. Here we're going to say angle BAC is congruent to angle CAD. I saw some measure of BAC is congruent to measure of CAD. That doesn't really make too much sense. That's just grammatical, not really conceptual though. the definition of congruency says if two angles have the same measure, okay, and that's something that I already know, it belongs in my if part, then they are congruent. That's what I'm trying to show in the step. It belongs in my then part. Okay. Now that these two consecutive or adjacent angles would be a better way of saying it, are congruent, I know that the larger angle got bisected. I'm going to copy down exactly what it is that I'm trying to prove. Ray AC bisects angle bad, BAD, and my reason would be if a ray, I don't care if you say segment or line here, splits an angle into congruent angles, and that was kind of the key word in my if part, congruent, what I already know, then it bisects that angle. Then it is a bisector, would have worked it. Then it bisects that angle is fine. Once again, bisect belongs in the then part because it's what I am trying to show. You lost a little bit of points for not numbering it. That would be why. Some people played the make your own theorem game, said things like if two angles are both 35 degrees, then the larger angle that made them was congruent. All right, state the triangle inequality theorem for only 1 point. I mentioned this a number of times in our review session. I think I repeated several times that every side of a triangle is smaller than comparison, so AN. The sum of the other two. And take that to heart to figure out what the restrictions on X are, I suppose, because there's multiple ones. If 3X plus 8 happens to be the largest side, it still has to be smaller than 8 minus X plus 7. That means that 3X plus 8, I guess, has to be less than 15 minus X. Let's add an X to both sides. 4X, let's subtract that 8, is less than 7. And X is less than 7/4. Perfectly happy with 7/4, by the way. That is one possibility. What if 3X plus 8 isn't the biggest side? What if 7 is the biggest side? It might be. I don't know what X is. So 7 would have to be smaller than 3X plus 8 plus another 8 minus X. So 7 would have to be smaller than, looks like, 2X plus 16. We could subtract 16 from both sides, get a -9, I believe. -9 is less than 2X, and divide by 2, and I get -9 halves is less than X. A lot of people got that, and then a lot of people left it there. Is there any reason why 8 minus X can't be the largest side? So what if it were? Then 8 minus X would have to be less than 7 plus 3X plus 8. 8 minus X would have to be less than 3X plus 15. Let's add an X to both sides. I'll get a 4X. Let's subtract 15 from both sides. I'll end up with a -7 this time. And if I divide by 4, I end up with -7/4 is less than X. X has to be greater than -7/4, which kind of preempts this one. -9 halves is less than that. It's got to be bigger than this. Then that's not so interesting. Okay, so my compound restriction looks like this. it's a little squishy in there. And put a box around it. Got it? Okay. Moving right along. A lot of people did great on the math part, not so wonderful on the reasoning part from time to time. Justify your initial equation with an if-then statement, a theorem, or a definition. So solving for x, they told me that BC is congruent to CD. So my initial equation is going to be that x squared equals x plus 6. How did I know that? Because if two segments are congruent, then their measure is equal. This is the worst case ever, is equal. Something like that. When they have equal measure would be another good way of saying it. So x squared minus x minus 6 equals 0. This is factorable. X minus 3 and then x plus 2 should do it. Negative 3 times positive 2 is that negative 6, and negative 3 plus 2 is negative 1. That seems to work for me. So x equals 3 or negative 2. Well, I have no objection to x being a negative, but I do have objections to lengths of segments being negative or even 0. So this guy gets the axe. I did need to see your work that got this as a possible solution, but I do also need to see that this is the only actual one. So x equals 3, solve for x, done, right? Is AB congruent to CD? In my opinion, I differ a little bit from other teachers. You guys use something which I like called the transitive property. Some people did. Said that, oh, you know what? If AB is congruent to CD, AB to CD, and we already know that CD is congruent to BC, that means that AB, this guy up here, is congruent to BC, that x squared minus 4 equals x squared. No, can't. And so some people justified it that way, and I appreciated that, and I gave that credit. But what was expected of you was, now that we know that x equals 3, we can say that A, B equals x squared minus 4 equals 3 squared minus 4 equals 9 minus 4, which is just 5. And C, D equals x plus 3, x plus 6, excuse me. That's at 3 plus 6, that equals 9. And say, no. Some people said, no, they aren't. Okay, well, that doesn't really help. The if-then statement would be if two segments do not have equal measure, then they are not congruent. It's really the inverse of that statement up above. It being a definition, inverses are legal. Getting down there, place a check in the appropriate box to indicate if the name is a valid name for angle AED. Angle AED is this angle right here, which goes from A to E to D. So if I said HEC, would it be the same thing? Yep, goes to the same angle. So yes. Angle E, on the other hand, could refer to any number of things, conceivably those straight angles, although I don't like it. Perhaps angle FEG, angle GEH, angle CEF, who knows? So it is not a valid name, and that is too ambiguous. Big US. Hopefully I spelled that right. Next up, we have an intersection. Intersections I like to do in 2 colors. That is the intersection of the ray DB, which starts at D and goes on forever in the direction of B, and the segment EF, which starts at E and ends at F I'm looking where these two things overlap, what is both blue and green, and there isn't anything. The correct answer should look just like that. This, on the other hand, is a union. I only need to do it in one color. I think my green was a little bit bolder. In fact, my daughter's marker is probably even better for this. Move some pages so it doesn't bleed through here. The ray CE starts at C and goes on forever in the direction of E. Looks something like that. The ray EG starts at E and goes on forever and then doesn't really bring anything new to the table. What ends up being green is still the ray which starts at C and goes forever in this direction. You could call it the ray CE, just like that, or you could call it the ray CG. There really is no other answer. It needs to be a ray starting at C and going in the direction of E or G. Or right out of C, G. Let's see what right. On to a little bit of logic here. The first one worth 3 points, the second one worth 2. The statement, happy people clap their hands, really translates as if people are happy, then they clap their hands. And on screen, yep, the converse, of course, is where I take the if part and the then part and switch them, leaving the if and the then in the same place. So if people clap their hands, then they are happy. Well, it didn't sound like a definition to me. I would assume that this is false. So I need to come up with a counter example. My counter example should be one where the hypothesis is true. So people are clapping their hands, but they aren't happy. I didn't really question it as long as it met that criteria. What I didn't like is sometimes people just said, yeah, it doesn't have to be true. Or people can clap their hands when they're not happy. Give me an example here. So places you might be clapping, I saw all sorts of different examples. A good speaker at a funeral, if you're square dancing, you have to clap your hands. Although I've never been square dancing and consecutively happy. So anything that you come up with where you are clapping your hands, but you're telling me you're not happy. So I clap my hands when, I don't know, I am listening to country music. I can tell you, if I'm listening to country music, chances are I'm not happy. When it's sunny, I wear my flip-flops. When it's not sunny, I do not wear my flip-flops is the second statement of logical conclusion of the first. This goes sunny goes to flip-flops. This goes not sunny goes to not flip-flops. That seems like an inverse to me, and inverses don't have to be true. So no, comma, inverses aren't always true. And to show that, of course, I'm going to come up with a counterexample. And again, I need an example where it is not sunny, and yet I am wearing flip-flops. So people said, I always wear flip-flops when I go to the beach, regardless of whether or not it is sunny. I wear flip-flops in the rain because they dry quicker. I wear flip-flops every day. Sure, any of the above. I don't think you need to see me write it down. There it is. Please let me know if you have any questions on that, on its grading, on anything geometric. And I will catch up with you today. When you're watching this, should be Wednesday. We X on Thursday. So I will catch up with you on Friday, it looks like. All right. Thank you.